So good morning, students. So my voice is audible. Please post in the chat box because I have been presented in both Meet windows. So
Yes, ma'am. Audible, ma'am.
thank you, sir. See, this is the revision number part 3. Okay. Show the given grammar which is ambiguous. Okay. So what do you mean by ambiguous? Which comes to the part of unit 3. Okay. What do you mean by ambiguous grammar? Actually, the most answerable peoples are available in the Meet window 2. I will expect the answer from Meet window 1. Post in the chat box. What do you mean by ambiguous grammar? Yes. The language or in grammar which one have more than one derivation tree. If you can able to draw more than one derivation tree for the same grammar means it will be ambiguous definitely. Okay, so more than one derivation tree means it may be a left derivation tree, right derivation tree. Else for a single grammar it is possible to draw more than one left derivation tree or more than one right derivation tree or left as well as right derivation tree means that grammar is ambiguous. We should avoid the ambiguous. Okay, but as per TOC syllabus it is enough to know what is ambiguous. Okay, uh, how to show the ambiguous. Okay, how to remove the ambiguous which is not part of TOC, it is a part of compiler design subject. Okay, so so I'm going to show, before I'm going to show the grammar is ambiguous, first I have found the strings which are accepted by this grammar. Okay, um, so I have to find the string. So I will write the grammar S, B, S. Okay, you can follow anyone. You can follow any left derivation or right derivation. Okay, so S is replaced by, first S is replaced by A. So A, B, S. Okay, then this second yes which is replaced by the first production rule. Actually there are two production rules. Okay, the second yes which is replaced by the first production rule, it is based on your choice. Okay, so I will move with my own choice. So S, B, yes. So next, so A, B, the first A which is replaced by A, then B, yes. Okay, so at a time you can replace only one non-terminal. Okay, so replace non-terminal with terminal. So in the last yes, again the last yes which is replaced by A, B, A, B, A. Okay, so this is the string. So I have found the string. The next step, based on the string, so I'm going to prove this grammar is ambiguous. Okay, so I'm going to draw parse tree because this is the mark which is given for this problem, which is a 6. Okay, so I'm going to directly draw parse tree. Else more than 6 mark means you have to write separately. You have to write leftmost derivation as well as rightmost derivation. Then parse tree for leftmost derivation tree and rightmost derivation tree. Okay, so I'm going to draw parse tree. So starts with S. Okay, starts with S. So parse tree for the string A B A B A. Okay, it is possible to draw uh, parse tree for a specific string. Okay, so A B A B A. So S is first. S is replaced by S B S. Okay. Uh, then this first S is replaced by SPS. Okay, the first S which is replaced by A. Okay, then the second S which is replaced by again SBS. Then the first is which is replaced by A, the last is which is also replaced by A. Okay, this is the parse tree AB, ABA. Okay. CAB, ABA. So this is the parse tree for leftmost derivation. Okay, leftmost derivation. So I'm going to draw parse tree for rightmost derivation. So S, which is again replaced by SPS. Okay. Then this S, which is replaced by uh, first SBS. Okay. Say I will choose. So A B A B A. Okay, this S is replaced by A. Okay, then and in the next step this S going to be replaced by S B S. So A again this S is replaced by A. A B A B A. A B A B A. So for this the string ABA has possibility of having more than one parse tree in the different format. Okay. So this grammar is ambiguous. See, I can able to draw different parse tree for the same string ABA. Okay. So thus the grammar is ambiguous. So this part is very simple. So the next one, this is the problem, part B problem, and this will comes in the part of the given is what? What's the input for this problem? Post in the chat box. What is the input for this problem? What they have given as input? Zero comma. What do you mean with 0 comma 1? Actually, they have given some sentence like 1, 2, 3, 4, 5, 6. Okay, 6 triplets values are available here. What is this actually? I will see in the other window. Yes, I got answer. Instantaneous description. Okay, instantaneous description of PDA, instantaneous description of a PDA, which is the input. They have given the input as ID of a PDA. So then construct a context-free grammar for the Puston deterministic automata machine. Okay. So you have to convert this PDA into context-free grammar. So this is the conversion of Puston automata to context-free grammar. So the given things, which is nothing but the instantaneous description of Puston automata. Okay. Sometimes they have given a transition diagram for Puston automata, which is as input, and you have, they will ask to construct context-free grammar, but that thing which is the least probability one, the most probability one, which is they have given the instantaneous description of Puston automata as input. Okay, it will be easy for you making some conversion. So solution. In the solution part, first I have to write starting state that is starting symbols. Okay, so every context free grammar have some starting symbol, like so a q naught, yes, something. So I have to write first. I have to write the grammar for starting symbol, which is mandatory for every push to automata to context free conversion. Okay. Okay, this step is which is common to so all the push to automata to context free grammar conversion. Okay, first I have to write the rule number one. Okay, so the rule number one, which is about starting a symbol as, then see here. Actually, before that, I have to write what are the non-terminals. Okay, so non-terminals here. So not like that. So no need to write the non-terminals. You have to directly derive the rule number one. So rule number one, yes, produced. See what is the starting state of this Puston automata. See here, the starting state of Puston automata here, Q naught. Okay, then starting symbol which is available on the tape, no, not tape, stack, which is Z naught. Okay, so starting state Q naught, then it starts with the stack symbol Z naught. Okay, it is possibility to go the same state. Okay, it is possible. So this is rule number one. So rule number one, which is about starting grammar. Okay, so yes, produce the triplets again. It will form on triplets. It starts with the starting symbol q naught, then stack symbol, then it is possible to have the same, it moves to the same state q naught. Okay, this is rule number one, which is applicable to all the push to automata to context free grammar conversion. So rule number two, again starting symbol. Okay, so again it starts with q naught, then the starting stack symbol which is z naught. It is possibility to move from q naught to q1 because here only two states are available. Okay, q naught, q1. So the number of states available in this push to automata, which is q naught, q1, only two. So the basic rules, it is enough to have only two, r1, r2. Okay, this is the basic rule. If number of states in push to automata 3 means q naught, q1, q2 means you have to write one more rule, r3. Okay, but no need to write R3 for this grammar because this grammar is having only two states, Q naught, Q1. So for Q naught, Q1, along with the stack symbol Z naught, the basic rule which is almost over. Okay. So these are all the instantaneous descriptions. Okay. So first I will take the first instantaneous description. This is the first one. Okay, so see here, this is the first instantaneous description, which is example for non-terminals. Okay, because it has, see, x is z naught. Okay, so x is z naught, actually this will part of non-terminal, and the second one epsilon. See, second one epsilon, which is the example of terminal. Third one x's, which is example for non-terminal cases. uh, Fourth one terminal case. This is also terminal. Okay, and this is also terminal because see here. Okay, so only two non-terminal cases remaining are terminal cases. Okay, so in the problem of push to automata to context free grammar conversion, the first step is to you have to write the starting production rules. Okay, so in the second step, you will take non-terminal. So you will write non-terminal production rules. So the first ID, which is example of non-terminal production rule. So I will choose the first one. Okay, so I will choose the first one. So in the first one means, see, so what is the first one? Del of Q naught 0 Z naught del of Q naught 0 Z naught, which is equal to the same Q naught comma X Z naught. Okay, two non-terminals are here, X as well as Z naught. Okay, Q naught X Z naught. So kindly please recall the previous sessions. See, if it is two non-terminals means that the possible combination of production rules are, how many possible combinations of production rules are possible? How many? Here non-terminal, two non-terminals, which is in the format of concatenation, X is that not, right? So how many rules are can able to form using this ID? 4. Good. Yes, 4. Okay, 4. So I will start with rule number 3. So rule number 3. So Q naught. First I will write Q naught. Then this one Z naught. Okay. Then this one. Actually, not this one. Not this one. Only two states are possible. Okay. In the four production rules, only two states are possible. So this Q naught, which is for already, sorry, only two states are possible, Q naught and Q1. And this Q naught, which is mean to this state only, not this one. Okay. See, almost the IDs of this problem conversion, Puston automata to context-free conversions, almost all the cases, uh, the thing which is like this only, X is not the case, and number of state which is equal to 2. Okay, so in all the problems, I have found in a textbook as well as n number of resources from the YouTube channels. Okay, actually, some rules are available with X is not the number of non-terminals, which is 2, as well as number of states, which is also 2. Okay, so this is your syllabus. So don't bother on if it is number of states, which is, if it is number of states Q0, Q1, Q2. So how can we proceed? Okay, so the number of terminals 3, X is not, and one more Y. Okay, so how can we proceed? Okay, don't bother on those situations. Okay, so your syllabus, which is having all the problems which is equivalent to this IDs only. Okay. So this is for Q0 case. So which is E tends to, because this is grammar. See, I will write this 0. So what is the input alphabet? This is 0, 0 off. Okay. Then I will start Q0 because it starts with Q0. So this Q0 will comes here, Q0, then X. This is the case for X. Then this is Q0 for Q0 case. This is ends with Q0, so again starts with Q0. Okay. So again starts with the Q0. So this case for X and this case for Z0. Okay. And it ends with this one here. It ends with Q0. So it is also ends with Q0 only. Okay. These are some few tips to remind such things in your mind. Okay. So this is rule number 3. So rule number 4, which is about Q0, Z0, the same thing only. Q0. Okay. The same thing, Q0, Z0, Q0, which moves to 0, again 0, because all cases are 0 only, because here in the input alphabet 0 is 0 only. So Q0, again this X case. Okay. This is the case for Q0 and this is the case for Q1. So previous one which is Q0 and this one which is Q1, it ends with Q1, so it starts with Q1. This case for Z0. Again C, it ends here which is Q0, so it is also ends with Q0. Okay, this is rule number 4. So what about rule number 5? Rule number 5 which is about ends with Q1 cases, that is Q0, Z0, Q1. Okay, starts with 0 only, then Q0, X, Q0. So this is case for Q0, it ends with Q0, so it starts with Q0. So Q0 is Z0. Okay, then see it ends with Q1, so here also it ends with Q1. Okay, so next R6, rule number 6, Q0 is not the same thing is repeated, Q1 0, then Q0 X, then it is about the case for Q1, it ends with Q1, so it starts with Q1, so is it not? Here it ends with Q1, so it is also starts with Q1. Okay, so this is the 4 production rules for the ID, first ID. Okay, your first ID, which is the example for non-terminal production rule. So 4 non-terminal production rules are produced. First, I will take the second non-terminal instantaneous description. That is a rule here, which is rule number 3. Okay. So I will take the rule number 3, ID number 3. Okay, not rule number, ID number 3. So your, what is your ID number 3? Del of Q0 0x, which is equal goes to Q0 xx. Okay. So del of Q0 0 x, which is equivalent to Q0 xx. So again 4 production rules are possible. So rule number 7. Okay, so rule number 7. So again Q0, it starts with Q0. Okay, this x, then which is this is about the Q0 case, this Q0. So it starts with 0. This is the input alphabet for this production rule. Then here it starts with Q0 for this case, X case, and this is the for Q0 case. It starts with Q0, so it ends with Q0, so it is also starts with Q0. Then this is for second X case, so here it ends with Q0, so it is also ends with Q0. Okay, so next also the same thing, Q0 X, Q0. Okay, so 0 Q0 X, this is the for the case Q1 case. Q1, it ends with Q1, so it starts with Q1, then X, Q0. This is from rule number 8. Next, rule number 9. Okay. So again Q0 X, this is the case for Q1. Okay. Again starts with 0. So Q0 X, Q0 case. It ends with Q0, so starts with Q0. Next X case, this is for it ends with Q1, so it is also ends with Q1. So next rule number 10, Q0 X, Q1. Okay. Actually, this is not equal. This is the production rule. Okay. This is the production rule. So work Q naught X Q1. So Q1 X Q1. Okay. So the production rules for ID number 3, which is over. Okay. So this part which is over, and so all the non-terminals part are over. Next, I will move with the terminals part. So ID number 2. So your ID number 2, see Q1 1x, right? Q1 1x, which equal to Q1 epsilon. Okay. So anyone, what is the what is the rule production rule for this ID? Actually, I will write the ID Q1 1x. So this is the ID number, rule number 2. Okay, so the rule number 2, this is Q1 1x, which is equal Q1 epsilon. Q1 epsilon. So I will check once again the grammar. Is there any wrong in the production rules? Kindly let me know. So I think all the production rules are the right one. Okay. Okay. This is your part. Say anyone. This is the ID number 2. So you have to write and this is the example for a terminal production. Okay. Okay. Q1 X Q1 X Q1 gives, okay, gives one case is enough. Production rules in the right hand side, one, that one will come. Okay. So I have received an answer from one window. So what about the other window? Don't left the meeting. So any answer from this window? Window number 1. See, this is the transition of del of Q1 1x equal to the same state Q1 only, Q1 epsilon. So I have to, I'm going to write the rule. Okay. Actually, this is actually rule number 11. Don't leave the meeting. So rule number 11. Okay. So del of Q1. Okay. So 1 minute. Q1 1x equal to Q1 epsilon. Okay. So not del of. This is actually, I'm going to write the rule. Okay. So Q1. So q1, this q1 will comes here, then this x will comes here. This is the form of triplets. Okay, next this is the case for a terminal case. Okay, so this q1 will comes here and it goes to this is your input alphabet 1. Okay, so this is the rule number 11. Okay, so q1 x, this q1 and this x will comes here and this q1 which brings 1. Okay, this is the rule number 11. So production number 2 which is over. So this production number id number 2 which is over. So I will take id number 4 q1 epsilon. Okay, q1 epsilon x which is equal to q1 epsilon. Okay, so I will write the id. Actually this is id number 4. Okay, id number 4. This is about id number 4. So id number 4 del of q1 epsilon x is equal to q1 epsilon x q1 epsilon. Okay, so I am going to write the rule number 12. So rule number 12. So q1 x, this x will come here and q1 which brings to this one, this epsilon. Okay, this is the rule number 12. So 4 which is over. Next which is about 5, q1 1x equal to q1 epsilon. Okay, so id number 5 del of actually q01x q01x equal to q01x equal to q1 epsilon. So the production rule, actually production rule 13 is equal to q0 and this x and this q1. Okay, which gives this in between what it is 1. Okay, next the last id. So this is over. The last one q1 epsilon is it not. Okay, so the last id, that is del of q1 epsilon is it not, which is equal to q1 epsilon. Okay, q1 epsilon. Yes, so the last reproduction rule, rule number 14. Okay, so rule number 14, this q1, this is it not, then this q1 which produced epsilon. Okay, so almost I have done all the production rules for the given instantaneous description. This part is almost over. Okay, it's in the last step. You have to eliminate the unwanted production rules. Okay, and the next step, you will give some renaming. You will make some renaming operation. Take one production rule. Example q naught x q1. Okay, this is the left hand side. You will replace this q naught x q1 replaced by a. Okay, so this is the last step. Okay, so in the first step, you will write some basic production rule R1 and R2, which is common to all the grammars. Okay, all the problems. In the second, uh, based on the given IDs, it will vary. In your given IDs, there are two IDs which is equivalent to non-terminal case. So first you will take the you will cover the non-terminal cases. Okay, so for single no, production for single ID, it will have four cases. So these are all about non-terminal cases, and this part are just about the terminal cases. Okay, so the remaining part which will cover in the last session number 6. Okay, thank you, students.